Hey everyone, welcome to Insights by Rish. In today's video, I am going to implement a project of Twitter sentiment analysis which falls under natural language processing domain. And for this particular project, I am going to make the use of this dataset which I have downloaded from Kaggle. I will provide the link of this dataset in the description box. Do check that. Now this dataset actually comprises of all the tweets made by the user as a review for various video games published. And you have the first column as the unique ID for every video game. Then in the next column you have the names of a video game. In the third column you have the sentiment, and in the last column you have the actual tweets. You want to input the video game name and the tweets made by the user, and you want to predict what is their sentiment. So let us import this dataset first into our Google Colab environment as I have did here, and next we will start implementing. Now before the implementation, I also would like to inform you that before you start implementing, change your runtime type from the CPU to T4 GPU, because this might take very longer to run all the processing part when you are using CPU. So hence switch to T4 GPU. And after that, I've already switched to that, and after that we'll start importing all the necessary libraries first. So let me label it as importing dependencies. Let's run that. So first we will import pandas as PD, and then we will import SpaCy library. You can perform this project either with the SpaCy library or with the NLTK library, that is the natural language toolkit, but I have preferred SpaCy here because it's more efficient than NLTK. As of now, we just require these two libraries. As we move ahead and we start implementing other things, we will go on adding the new dependencies here. So let's run this, and now let us load our dataset here. We'll say pd.read CSV, and here I will provide the path of the dataset. Let's run that, and let us try to display the dataset. Now when you take the look at this dataset, you might find you have some unwanted columns here, like the first column. You don't require the unique ID of every video game. So the next thing that we are doing here, we will delete the unwanted column. So we'll say df.drop columns is equal to 2401, and we'll say interest is equal to 2 in order to make our changes permanent. Let's run that, and let us again try to display this. Now we don't have that column, but again we have some problem here, that is we don't have authentic column names here. The dataset or the CSV file basically consists of first row as the column names. We want to name these columns now. So the next thing that we are doing here is renaming columns. We'll say df.rename columns, and here before this cell I will just load the all column names. So the first column is Borderlands, and I'm going to rename it as the game name. It basically consists of all the video game names. The next column here is Positive, and I'm going to rename it as a sentiment. It basically consists of all the sentiments here. You don't require this extra bracket actually. And the last column here that we have is, that's a large column name actually, and we are going to rename it as the tweet. That's the actual tweets made by the user, and we'll say in place is equal to true. Let's run this, and let us again try to display our data frame. Now as you can see, we have renamed our columns to some valid names. Now the next thing that we want to do here, we will check for our missing values, and if there are any, we will handle them. So let me write the label here, handling missing values. Let's run this, and we'll say df dot is in a sum. So we have 686 missing values in the tweet column, and when you check the dimension of the entire dataset, that is df.shape, it consists of 74,000 rows. So deleting 686 rows won't affect the entire dataset or our model, so we'll just delete them, we'll just drop them. So we'll say df.drop NA. And let us now confirm that we don't have any null values right now. So we have handled the missing values. And now the next thing that we want to do here, if you take the look at this dataset and its dimension, it consists of 74,000 rows. But if you try all the text processing and all the data pre-processing part on the entire 74,000 rows, it will take a lot of time to do so. It will take around 1 hour or even more than that. And it might happen that you run out of your memory. The good practice is what we will do. We will just create a new dataset of 8,000 rows and we will include 2,000 instances for every sentiment into that dataset. So by that what I basically mean is, let us try implementation and I will explain you along with that. So we are creating a new dataset. Let's run this. So what we will do, if you check the unique values from sentiment along with the value counts, you will find that every sentiment, or you can say every sentiment like negative consists of 22,000 rows, positive consists of 20,000 rows, neutral consists of 18,000 rows, and irrelevant consists of 12,000 rows. So what we will do, we will extract 20,000 rows from every sentiment and create a new data frame out of that. This is because we can just randomly create 8,000 rows, or you can extract randomly any number of rows from the original data set, but that might result into imbalanced data set. It might happen that you have many number of rows for some particular sentiment, and for other sentiment you have comparatively very less number of rows. So we want our data set to be balanced, and hence we will manually create that by extracting 2,000 rows from every sentiment. So first data set is positive. We will say df, where df dot sentiment is equal to positive, and we want the first 2,000 rows here. So we'll say first 2,000 rows. We will repeat these things for the negative as well. So we'll say negative, actually the sentiment is equal to let's run that. And now we will create a new data frame out of that. So let us name that as df2, and we will say pd.concat. We will provide all these data frame names, that is df positive, df negative, df neutral, and df irrelevant. And we are concatenating it on the basis of rows. So we will say access is equal to 0. Now when you check the shape of our, so the issue here is df irrelevant and it's basically underscore. Now when you check the shape of your new data frame, that is the df2, you find that you have 8,000 rows now. So you have reduced the number of rows here, and you have equal number of samples for every sentiment. If you try to check the same thing on the data frame 2, you will see that you have 2,000 samples for every sentiment. Now let us try to display it first. Now what you will do here, you basically want to perform data conversion, that is the data transformation here. You have a categorical column of game name here, and you want to convert it into the numeric one. So what you will do, the next thing that we are performing here is categorical to numeric data conversion, or you can say data transformation. Let's run this, and let us try to check the unique values from the game name. And you have this many game names here. As you can see, you have Borderlands and all this unique names. So what we will do here, we will use the one-hot encoder to convert the categorical values into the numeric ones. So we'll create a new data frame of game df, and we will say pd dot get dummies, and here we will pass the column that we want to convert. So the column that we want to convert here is game name, and I think the issue here is okay. Let's run this and let us try to display our data frame. Now when you take the look at this data frame, it basically consists of values in the true and false format. This is because you haven't explicitly converted the data type. You need to convert the data type explicitly. So we will say as type int, that is the explicit conversion of data type. So as type int. Let's run this. And now you have the values in the form of zeros and ones. Now we will delete the game name column from the df2 because we don't require it anymore, as we have already converted it into the numeric form. So we'll say df2 dot drop columns is equal to game name, and in place is equal to true. Let's run this and let us try to visualize our data frame. So now this is our new data set. You don't have that column. We want to concatenate this particular data set with our game df, but before doing that, let us check the shape of both df2 and also the shape of game data frame. So both consist of 8000 rows. Now actually, before concatenating these two data sets, we will perform text pre-processing on this tweet column. So the next thing that we are doing here is text pre-processing. Now what we will do here in text processing, we will convert all these words from the tweet into their root words, and we will also remove the stop words and the punctuations. So first we will say NLP is equal to SpaCy dot load the English module, that is en core web small. Let's run this. So this is our SpaCy pipeline that we have loaded into an NLP variable. Now we will write a function of lemmatization which will basically extract individual rows from the tweet column. Then it will pass that individual rows to the SpaCy pipeline that we have loaded in the NLP variable, and it will extract every word from that individual sentences and will convert that words to their base form. So let us write the function. So lemmatization, it will take a text, that is the individual rows from the tweet column, and we will say doc is equal to NLP on the text, that is we are feeding that individual rows from the tweet column to the SpaCy pipeline. Now we will write a list comprehension code snippet here. So we'll say lemma list is equal to word.lemma for word in doc. And we will actually join that, because if you don't join that, it will return all the base words in new rows, but we actually want in the same row. So we will say dot join your lemma list. Let's run this. And now we will apply this function on this tweet column, and we will store all the transformed values into a new column named as lemma, and we'll say df2. We will apply it on the tweet column, and we will say apply lemmatization. Let's run this. So let us try to display the data frame. This is our new column lemma, and we have converted all the words into the base words. If you take the look at the first instance, you might find that the word coming is now converted to come. In same way, the borderlands word is now converted to borderlands. So you are removing basically all the suffix and prefix and converting the word to their base words. The next thing that we want to do here is we are going to remove all the stop words and the punctuations from this lemma column. So let us write the code for that. Def remove stop words. Stop words basically means the word that don't make any sense individually. Like if you take the example of first instance, then if you divide these words into the individual one, you may find that the word come or the word border and the word kill makes sense individually as well. You are getting some gist from that single words. But if you take the words be or I and, you don't find any context by just looking at this individual words. These are the stop words that you want to remove, and let us write the code for the same. So we'll say text, we'll do the same thing. Doc is equal to NLP on the text. Here we are extracting every individual row from the lemma column in the text, and now we will write a list comprehension code snippet here. So we'll say no stop words is equal to word dot text for word in doc If not, word dot is stop, and not word dot is punct. So basically what we are doing here is we are extracting every word, that is the word dot text, except for the word that it shouldn't be a stop word and it also shouldn't be a punctuation, and then we will join that. So return dot join the no stop words. Let's run this, and we are going to apply this function on our lemma column and store the results into a new column. So let us name that new column as final, because we don't require any more pre-processing further. That's all. We just wanted to lemmatize it and wanted to remove the stop words and the punctuation. So this is our final column, and we will say df2 lemma dot apply this function of remove stop words. Let's run that. Now let us try to display our new dataset. And as you can see, the sentences are reduced to very short, as that is, all the stop words are removed in the final column. Now we don't require the lemma and the tweet column, and hence we will delete that. So we'll say df2 dot drop columns is equal to the tweet column and the lemma column, and we will say in place is equal to true. Let's run that and again try to display the dataset. This is what we want. This is basically our final column and sentiment column. This is our target feature, and finally our input feature. Now we are going to concatenate this particular dataset with the game data frame that we initially had. As you can see, this particular one. So let us concatenate that, and we will store that into a new data frame. Let us name that as sentiment df. So we will say pd dot concat, and we'll provide the name of data frames. First is df2 and the next is game data frame. Now we are concatenating these data frames on the basis of columns, and hence we'll say access is equal to 1. Let's run that and let us try to display it. As you can see, now we have the sentiment column, the final, and all the video game names. Now once we'll just check for the shape, and we'll confirm that there are no missing values here. Fine. Now the next thing that we want to do here, we are going to divide our dataset into the input features and the target feature. So let us store, first let me write the label here. And let us say the X data frame will store all the input features. So basically we want to involve all the columns from this sentiment data frame except for the sentiment column. So we'll just drop that. We'll say sentiment data frame dot drop columns is equal to sentiment, and in the Y variable we will store that column, as this is our target feature. So sentiment df, the sentiment column. Let's run this and let us try to check the input data frame. So this is our input data frame which we are going to supply to the model. Now before supplying this to the model and before building the model, the thing that we want to do here is we want to process this final. This final consists of all the text, and we need to perform TfidfVectorizer here. Now if you want to know about the TfidfVectorizer, I have already explained about that in brief in my previous video of spam message detection. Here I will just show you the implementation. So the next thing that we are doing here is TfidfVectorizer. So we just want to apply this TfidfVectorizer on the final column because it only processes on the text column and not on the numeric ones. So we'll import the dependency first. We'll say from sklearn dot feature extraction dot text. You will import the TfidfVectorizer. Let's run this. And now we will create an object of that here. So we'll say TfIDF is equal to TfIDF vectorizer. Let's run that. And then we are going to fit this final column into this TfIDF. So we'll say TfIDF dot fit from X. We are going to fit the final column here. Let's run this. Now we will create a matrix of this. So we'll say TfIDF matrix is equal to TfIDF dot transform. You can go you can perform this fit and transform in one single go, but I am doing that separately. So I will say that I want to transform the X final column from the X data frame. Let's run this, and when you try to display your TfIDF matrix, you can see it will give you something like this, 8000 into 6720 sparse matrix here. So to display this in an array format, we can just write here to array, and let's display this. Now we will create a new data frame of this vectorizer. Let us name that as vectorizer. We'll say vectorizer df is equal to pd dot data frame, and here I will supply this TfIDF matrix, and my column names would be the individual words or individual tokens that I've extracted from the final column. So I will say columns is equal to TfIDF dot get feature names out. Let's run this, and let us try to display the vectorizer df. As you can see, you have a new column for every individual word, and you have 6720 columns now. Now the next thing that we want to do here is we actually want to drop the tweet column, or you can say the final column, from this particular data set, and we are going to concatenate this particular data set with the newly created vectorizer df. So firstly we will drop that. So x dot drop columns is equal to final, I think f, okay, it's f is small, and in place is equal to true. Let's run that, and after that we will say just let me check the shape of x and also the shape of vectorizer df. So you have 8000 rows in both, so we are basically going to concatenate that. Let us say we will name that x only, so we will say x dot pd concat the x, and the next data frame is vectorizer df, and we will say access is equal to 1. Let's run this, and let us try to display. So the concatenation, let us display. So now this is our input data frame, which basically consists of 6725 columns and 8000 rows. We will just confirm that we don't have any null values here. We have some null values here, so what we can do, basically we can just fill it with 0. So we'll say x is equal to x dot fill in a with 0, and let us again check for null values. Now we don't have any. So after that, what we want to do is we are going to divide this data set into the training set and the testing set. So let me name it as train, test, split. So first I need to import the dependency here. I will say from sklearn dot model selection, I am going to import train, test, split. Now here I will say x train, x test, and y train and y test. Here I will provide my input data frame, which is x, target feature, which is y, and I will say test size is equal to 0.2, and random state is equal to 42, which means 80% data will be stored in the training set and 20% in the testing set. Let's run that and we will try to train test bit. Okay, we haven't let us run this cell. Let us rerun this, and it's saying that found input variables with inconsistent number of samples. Let us check what's happening. We'll say x dot shape and y dot shape. So in your input you're having 8,900 rows, but after concatenating you are getting some extra rows. So we will basically say here x is equal to x dot I location, the first 8,000. Let's run that and let us again check the shape of x. So now we have consistent samples. Let's run this and then we will check the shape of our x train and x test. So out of 8,000 rows, we have 6,400 rows in training set and 16,000 rows in testing set. So we will now build our model. Let us name it as building model. So I am going to use random forest classifier here. You can use any algorithm you want, but I performed grid search CV and I checked which algorithm would be appropriate, and from all the algorithms I got best accuracy using the random forest classifier, hence I am preferring that. Let us import the dependency first. I will say from sklearn.ensemble we will import the random forest classifier, and we'll also import the evaluation metrics here of classification from sklearn.metrics. I will import my accuracy score, then classification report, and then the confusion matrix. Let's run this, and now we will create or we will build the model. So we'll say model is equal to random forest classifier. Here we will pass n jobs is equal to 1 because we want the parallel processing, and we will say random state is equal to 42, and we will also say n estimators. This is just some hyperparameter tuning. N estimators is equal to 200, and then we'll say model.fit x train and y train. So we have built our model. Now we'll make some predictions and we'll store that into the pred variable. We'll say model.predict for x test. Let's run this and we'll try to compare the original values with the predicted one. Let us display the first 5 true labels from the y test. So the first 5, and the first 5 sentiments are basically 2 negative, 1 positive, again 1 negative and neutral. And let us check what our model has predicted. And the predictions are different. So let us try to check the accuracy here. Accuracy score. We will pass the original values which are stored in y test and the predicted values which are stored in pred, and we'll multiply it by 100 as we want the predictions in percentage. So we are getting an accuracy of 71%. This model is giving us an accuracy of 71%. Next we will try to display the classification report. So we will say print classification report, and I will again pass this y test and y pred here. As you can see, we have 4 categories and we have the precision and recall for all 4 categories. F1 score is close to each other. This is because our data set is balanced. Now let us try to display the confusion matrix here. So first we will build the confusion matrix. We will say confusion matrix. Here I will pass the true labels which are stored in the matrix, the predicted labels, and then I will say normalize is equal to true. Then I will plot the confusion mat using the Cbun SNS. I think I have loaded the Cbun here. No, I haven't. So let me import that. Import Cbun as SNS. And then we will say SNS.heatmap. We will pass our confusion matrix and not is equal to true, as we want our values to be displayed on the grid, and we will say CMap, that is the theme of our heat map, to be crest. You can give any theme you want. Let us try to display this. And this is our confusion matrix. If you want, we can label it. We'll say PLT. I haven't imported the matplotlib as well, so let me import that. Import matplotlib.pyplot as PLT. Let's run that, and let us say, actually here, plt.xlabel. On the x-axis we have all the predicted values, so predictions, and on the y-axis we have all the actual values, so y label is actual. And let us also give a title, so we'll say plt.title, and we have the confusion matrix for sentiment analysis. Let's run this. And this is our confusion matrix for sentiment analysis, as you can see. So on the x-axis we have predicted values, and on the y-axis we have actual values. So if you take the look at the diagonal, it actually gives you the accuracy for correct predictions. So if for the first, that is the first sentiment that we have is irrelevant, 73% times it's happening that the original sentiment is irrelevant and the model is also predicting the same thing. 59% times it's happening that the sentiment is negative and model is also predicting the same thing. So if you take the look at diagonal, it basically gives you the accuracy of correct predictions. This is our confusion matrix, and the accuracy this model is giving us is of 71%. So that's it for the video. Thanks for watching.